Hello, everyone. Thank you for coming for my talk about Scala 3 transition from Scala 2 to Scala 3. And there's an interesting pun in the title that hopefully by the end you may understand. So remember this: taste the difference with Scala 3. How are we going to migrate the Scala 2 ecosystem into the Scala 3 universe? And let's see. Okay, so about me, I'm Jamie Thompson. I work at the Scala Center, which Daria talked about at the keynote just now. I work on the Scala 2 and 3 compilers. I'm working on tools related to migration from Scala 2 to 3, such as adding semantic DB support to Scala 2. And you can, to Scala 3, sorry. And you can see me on GitHub and Twitter. Okay. So today we're going to be focusing on maintainers of Scala 2 projects, so libraries and applications. Now that Scala 3 is coming, what is so new about it, and why should Scala 2 developers care, and how can they have a smooth transition for their code from Scala 2 to Scala 3. And as we'll find out later, we'll find out why pickles are not tasty. Okay. So Scala 3 is a new programming language. Well, it's a new version of the Scala programming language. It's a new implementation from the ground up. Implementation started in 2012, and now it's hopefully by the end of this year, or maybe later, it will become the official Scala 3. And under the hood, it has some new technologies that we'll be using in this story to have a smooth transition from Scala 2 to Scala 3. And of course, it has lots of new toys. So to help scripting, we can now write a single line program by adding this annotation main to any function. And then here we're compiling a program and running it in 2 lines. Another new feature in Scala 3, which is quite fancy, is we have enums, which is a simpler version of writing an algebraic data type. So at the top, we have the Scala 2 version, and then at the bottom, we have what you would write in Scala 3. As you can see, it's a lot more concise and simple to read. And a big new feature that recently was added is null safety. So if we look at this code to pretty print some recursive data structure, if we look at the current line highlighted, this is a nullable value that we can't use because it could be null. And then we test in this loop that it is not null. And now inside the body of the loop, we can use current safely and call methods without ever fearing a null pointer exception. Very nice. Okay, so there's plenty more new features that you can find on the Dotty website listed below. So now we've seen what's new. What does this mean for the thousands and thousands of projects out there already written for Scala 2? You know, people depend on these to make a living. How will this impact them? What is the cost? And what are the opportunities? So I imagine there are 2 main scenarios. Let's say you are a Scala 2 application and you are depending on some library published for Scala 2, and you want to migrate your code to Scala 3, but you still want to use the same libraries because they haven't upgraded yet. How is this possible? The second scenario is that we have a Scala 2 application and depending on a Scala 2 library. But the Scala 2 library is now moved to Scala 3 and added some new features, some new goodies. But the Scala 2 application, you don't have the time yet to invest in transitioning to Scala 3. So in the future, it will be possible to depend on this library that's been published for Scala 3 from Scala 2. Now, this is a kind of new scenario that we haven't really had before. So how is that possible? And finally, let's just take a look and say, are we going to repeat the mistakes of the past? Is this going to be the same as the transition from Python 2 to Python 3? And I say no. The issue with Python is that it's dynamically typed, and it's hard to see the differences in breakages in APIs. But in Scala, we have typed APIs, and we can verify that with testing that the API will still be compatible in your new version, and we can warn you about any breakages. And we are promising that between Scala 2 and Scala 3, they'll have the same representation at runtime so that there won't be any confusion. And as I showed you before, you can depend on libraries from either version. So you can depend on Scala 2 from Scala 3 and Scala 3 from Scala 2. So how does this work? Let's take a look at transitioning your own application to Scala 3 and how can we depend on some libraries published for Scala 2. So there are basically three categories of changes you need to consider when migrating code. These are enforced changes, and we'll take a look at those later. Source stability issues, and we'll take a look at that. And how you can evolve your code later. And basically, these migrations can be performed in two stages. We could say that while you're waiting for Scala 3 to come out, you can make some preparations in Scala 2 and still publish your code. And then once you transition to Scala 3, you can then apply the next step of transitions. So what are enforced changes? These are basically features that no longer exist in Scala 3. So they will cause a compile time error. And if you compile your code using the flags, then basically you'll get a nice warning or an error telling you what's wrong with, for example, having a do-while loop. It will tell you that you need to change it into a while-do loop, and it will give you a little example of how to do that. Although some features, like here we can see that highlighting of abstract type projection, this feature is no longer valid in Scala 3, and you just get a hard warning, hard error telling you it's not possible. So you need to look at the documentation that will tell you the migration steps for this. So what do I mean by source stability changes? These are basically changes to things that the Scala compiler fills in the details for you. So whenever you fill in implicit values, or whenever you try and do type inference, or whenever you try and work out which overloaded method you're calling, these are all guesses made by the compiler, and these may have slight differences between Scala 2 and Scala 3. So what we recommend is that you, on all your public APIs, you always annotate the return type. This is so that type inference doesn't change your API between different versions. And also the rules have changed for implicit resolution, so where your implicit values appear in scope. And also there's some different rules for overloads, such as curried parameters change the way it's selected. So at the Scala Center, we develop a tool called Scala Fix. It's a tool that can lint your code and also perform some automatic rewrites. And we are developing some new rules to help you, for example, annotate your public types. And also, you should just check with testing that your behavior doesn't change between Scala 2 and Scala 3. So once you've made all these changes and Scala 3 is published, there are basically a few things you have to think about. For example, the Scala 2 macro system is no longer valid in Scala 3. So basically you will need to rewrite your Scala 2 macros in the new library, which is being written by Nicholas Stuckey at LAMP at EPFL in Switzerland. This is all detailed on the Dotty website, but basically if you have your Scala 2 macros in one set of sources and then your Scala 3 implementations in another set of sources, you can cross-compile and still have the same API. So that's one change you have to think about. And then in the future, there are many new features of Dotty and Scala 3, such as new syntax for the enums that I showed you, or new syntax for implicits. And these things may break cross-compilation. So as they add new APIs that don't exist in the Scala 2 library. So basically, we need a way for Scala 2 to be able to depend on Scala 3 libraries that make use of these new features. So how will we make that happen? So taking a look at this scenario where we have the Scala 2 application depending on a library that's now published for Scala 3, how does it work? So in the past, basically what we have is we have a build tool that you tell it which version of Scala you're using, and then it uses the Scala compiler, for example, 213. It takes some source files and it transforms them into JVM class files. And this is a runtime binary representation that the JVM runs your code with, and it's not the same as Scala. Basically, we lose some information, and I'll be showing you later some of the ways that this loses information. So basically, the Scala compiler trusts code that it knows how to compile. What I mean by that is that once you've compiled a library into a jar file, which could be a library or an application, you publish it in a central location such as Maven, and then your new applications, if they depend on a library such as a database, basically Scala only trusts code that has been compiled if it's compiled by the same version that you're currently using. So the build tool, for example, the reason I've tagged 213 on here is that you need the 213 compiled library in order to trust that at runtime you'll have the same binary interface. And we'll take a look later at how that works. So here what we got is that we have B Scala is a new application that depends on these two libraries, and we take the 213 tag, and then we publish it, recompile and publish that with the 213 tag, and because they're both 213, they then link at runtime. The new thing with Scala 3 is that this rigid restriction that we have to use the exact same tag is changing with Scala 3. So the reason it's happening like that is because we have a new compiler, Dotty, which is the blue cube on here. I've shaped it different because they have literally different, it's a brand new compiler, there's different internal representations of your program and different ways to understand libraries that have been published to the internet. So how do we get them to understand each other and compile code that have been compiled with the other? So for example, if we say we have a Scala 2 library that tries to depend on a Scala 3 library, the square hole, or we have a Scala 3 library, Scala 3 code depending on a Scala 2 library, the round hole, are we going to have the issue that they don't see how each other works? So this is not an issue. We're not going to have square pegs and round holes. Basically, we have what I call a asymmetric union. Basically, Scala 2 and Scala 3, they're going to have a very happy time together because they will be able to depend on code compiled by the other, but through different mechanisms. And I'll show you how that works. So how do we get code compiled with Scala 2 to depend on libraries compiled with Scala 3? Basically, we have to have two different considerations. We have to make sure that at runtime they compile the same code, and at the runtime that code is compatible with each other. And then we also have to look at when you're depending from libraries that the APIs, the Scala APIs, match. So what do I mean by that? If we take a look at the runtime, basically Scala compiles code to the JVM, and that Scala has features that the JVM does not have. So, for example, in the highlighted box, we have a value class, which is basically a way to have an unboxed representation, like a wrapper around a value, and then at runtime it's unboxed. But the JVM doesn't have any knowledge of that, so we have to basically transform it into some sort of equivalent Java code. So that means that from either Scala 2 or Scala 3, when you compile this highlighted expression, we need to make sure that on the JVM we have this code outputted. So they have to both agree to compile this code to that code. Otherwise we'll have basically a runtime error, which is not good for anyone. So basically we are unifying the runtime representation of Scala 2 and Scala 3. Things like, as I showed you, value classes are the same, and so are default parameters and other features. But one sticking point at the moment is that traits have a different implementation, but we will unify them by the time Scala 3 comes out. So the other story for is that when you depend on libraries published that have already been compiled, because they've been compiled to class files, that information has been lost. For example, after type erasure, which is basically we take a class in Scala, we say we have this class math, which is one method, and it takes a list of ints. Okay, so when it appears in a class file, it actually looks like this. So we say that the list of int has now become a list of objects, and basically this causes a problem because if we look at this Scala type system, we have at the very top we have any, which is any value at all, and then on the right hand side we have object, which is the Java top type, and then basically int is not related to object in the Scala type system. So that would so if Scala just saw the class file with the list of object, then you wouldn't be able to pass a list of ints to it as you would hope, because those types are not related. So in the class file, there must be some extra information that Scala knows about in order to read the original signatures that you compiled from. So so we still need that is a list of ints in the class file somehow. So how does that work? So in Scala 2, when you compile your Scala source code into a class file, we annotate the class file with Scala pickles, and what this is a binary format that basically lists the public API of everything in that class file with the full Scala types. But it doesn't have the implementation, it just lists basically the arguments and the return type. So that's how we get the information to store that is a list of int. In Scala 3 this is different, we have a different representation, we don't use pickles. So how do we get Scala 3 to depend on Scala 2 libraries? We have an implementation that understands the Scala 2 pickles, and it's pretty much 100% compatible except for one feature, which is existential types, which have been dropped. But if you have an existential type and it can't, and Scala 3 doesn't understand, it will tell you where you need to change, and then there's documentation for how to do that. So what does Scala 3 do to store these signatures in the class files? What we do instead is, instead of pickles, we have Scala code compiles, we get a class file, and we get this new file called tasty file that is linked to the class file. And what is tasty? It's essentially it's a complete representation of the Scala 3 language with the Scala 3 type system, but it has all the implementation details. So it's different from pickles. Pickles only has the signatures, but tasty has everything, all the information. And we produce tasty after we've done type checking, overload resolution, and implicit resolution. So the compiler does not have to do any guesswork. All the details have been filled in. So if you need an implicit conversion to get an extension method, if you have loads of overloads of carried parameters and you need to select the correct implementation, or if you haven't annotated your types and basically all that information has been filled in by the Scala 3 compiler before it produces tasty, but then this tasty file is produced before we do any of the JVM transformations. So it's basically all the information needed about your program. So why is that important? What that means is that if, for example, in a future version of Scala, the JVM representation changes, for example, like I showed you before with the value types, if we change how those work, then then basically we can take your tasty file and recompile it and turn it into a new set of class files with the new API, and it will be the same program. It will have the same meaning because we have all the information. And the compiler doesn't do any guesswork because it's already worked out the inferred types or the implicit values. So this is why is this important for Scala 2? Basically, we use tasty in the same way that Scala 2 uses pickles. So Scala 2 will read the tasty files and understand the signatures that exist as Scala 2 understands them, and not as the JVM understands them. And it will also allow us to do analysis of your programs in the future with new tools such as different, more fine-grained ways to check if your API has changed between versions. Basically my work at the Scala Center is to make Scala 2 understand tasty. And so by the release of Scala 3, we'll have Dotty be able to understand Scala 2 pickles, and we'll have Scala 2 be able to understand Scala 3 tasty, and we'll have the same runtime representation. So that means we'll have this bidirectional synergy between them, which will allow you to do those dependencies that I showed you. So I'll do a demonstration now of a Scala 2.13 application that is depending on a library called Zio, published for 2.13, and will basically change the version to a version published with Dotty, Dotty version 0.20, and we'll see that that it no longer compiles because it doesn't understand. Scala 2 won't understand the Dotty file, and then we'll change the Scala version to a version that supports tasty, and then it will recompile. Okay. So if we see here, we have a Scala 2 project, and it is built with Scala 2.13.1, and we're depending on the Zio library 2.13. And basically what it is a simple console application that will just ask me my name. And the reason I'm showing you this example is because we use quite a few unique features of Scala. We have operator names which don't exist in Java, and then we also under the hood use some intersection types, which is not a feature of Scala, and then a feature of Java. And then inside here we are using a value class, as we can see here, which is not a feature of Java. So basically there's many things that are Scala specific going on. So I'll just show you this code running. So hello, what is your name? Hello, Jamie, you have a great FBI conference. Okay. So now if I go to the SBT and I change this version to the Dotty version of Zio, and then reload that, clean, and then run. So basically we get a bunch of compile errors because basically Scala 2 sees this as weird code that it doesn't understand. It basically thinks it's Java, so it doesn't work. So basically we're going to change our Scala version to the one that has tasty built in, and reload. Now we compile, and hallelujah, it works again. Okay. Okay. Thank you. And what you've seen just then is basically it's a code base on GitHub that you can take a look at today. Scala Center Tasty Reader Compat Test Kit. What this is just a basic SBT project, and we have dependencies that are published with Scala 3, and basically we want to add new libraries so that we can validate that our Scala 2 implementation does in fact work with all your libraries. So please submit a pull request with your own libraries, and we can help each other. Okay, so what is the eventual impact of everything? Basically, what we have here is we can imagine that this is a graph of all these Scala 2 libraries and applications that have various dependencies. And basically, we want to say that why can't one anywhere in the middle just flip to Scala 3 and everyone else will still be happy? There's no going to be no queuing up to release all on the same day. So basically, this will, because we have the bi-directional dependency, it means that anyone can depend on Scala 3 from Scala 2 and depend from Scala 2 from Scala 3, and then everyone will just gradually flip to the new version until we conquered the universe. Okay. Okay, so let me just recap. We took a look at Scala 3 and what's new with it, and also we're hopefully the takeaway you'll get from this is that we can have this smooth transition from Scala 2 to Scala 3, and it won't be a big rush, and that we won't repeat the mistakes of the past. And maybe if you pay attention, you saw why pickles are not tasty. Okay, so thank you very much.